Today, our lecture name is Work, Power, Energy. One by one, we will explain all this concept, whatever will be important. Let's start from work. Work done by some forces. I want to start with the meaning of work. Look, in a real life, in a real life, meaning of a work is different from physics levels. Okay, from physics. In physics, there is a different definition of work. So don't think that whatever will be work in the language of physics will be also for real life. No, there is a different between them. So work means here we will have a angle, direction. Okay, direction, angle, direction. We can define it by this formula. F is equal to FD. FD. Now this is a formula. Now this is a formula. Look at over here. It is a work will be defined as a product of what? Product of this is a product of force and displacement. If a force I am applying in this direction, so displacement, this object is displacing in the same direction will be our work. Okay, will be our work. And details we are going to explore it. If over here it is a force and D is a displacement, okay, or you can replace a D by S. It's your choice. It's your choice. Right now, just understand this is our F into D. This is not a standard. Okay, this is not a standard. A standard would be W is equal to integration F D. F D. This is our standard. So work done by constant. First of all, we will say work done by a constant force. We will have a variable force. Variable force. Here we are going to start with constant force. If we apply constant force on object, then what will be work done? Okay. Assume if this F vector, remember this F vector, this is a vector. Okay. If it is vector, of course, it will provide direction. But over here, work W is not a vector. This is a scalar. Okay. We know that multiplication of two vectors can provide what? A scalar quantity. So the scalar quantity is over here. F is our vector, D is also vector. But multiplication of these two vectors is providing a third scalar quantity, which is a work. So remember, work is not providing direction over here. Okay. If the body goes through a displacement, again I am telling you, the body is going in this direction, and I also applied a force in the same direction. Then the work done by the force is given F dot D, or you can say S. Okay. S. Try to understand. You know, when it comes to a scalar, we use what cos theta. Yeah, we use cos theta. So W is equal to F into S. F into S. So cos theta. So angle over here we have what? 0 degree. What? 0 degree. I applied in this direction. I applied force in this direction on the object, and object is going in the same direction. It means rotation, amount of rotation is 0 degree. So finally we will get F into S. Cos 0 degree is nothing but 1. Okay. So this F into S came from this equation. W is equal to F into S cos theta. Okay. F magnitude of a force over here, over here we have a magnitude of a force and s magnitude of a displacement. We are not taking direction. Remember, we are not taking direction. If it, this was a definition of a, this was a definition of a work. Now let's move. Now let's move on some important points that we have to keep remember in our mind for work. Okay, for work. For work. First is first is first if theta is acute angle, remember, if theta is acute angle, we will have three or more angles. For example, acute, obtuse, right, straight angle. Right now, just understand what is acute angle. Acute angle means angle whose value is less than 90 degree. Okay, this is known as acute angle. So if theta is acute angle over here, if angle is less than 90 degree, then our work done will be positive or negative or constant. This is what we have to identify by observing angle. So here condition is if angle is less than 90 degree, then remember our work done will be positive. Okay, our work done will be positive. Positive. Reason is angle is less than 90. 90. When you go ahead of 90 and less than 180, then values that you will get will be negative. That's why we say work done will be our minus v. Reason is if you put cos 120, you know that cos 120 will be providing negative sign. Okay, that is what is the reason. So all the values that are coming from cos angle. Okay, from cos angle. Now next, what if theta is so theta is obtuse angle, then if theta is obtuse angle, so remember our work done will be negative. Now if theta is 90 degree, then remember 90 degree cos 90 will be what? Cos 90 will be uh, cos 90 0. So work done will be 0. Remember, work done will be 0 because cos 90, value of cos 90 is 0. Now let's visualize. If we are applying force downward and object is over here, will body, if we apply downward force on the object, will body displace in this direction or in this direction? Your answer will be no. Body will not displace at all. That's why we applied force, but there is no displacement. Okay, so there is no displacement. Reason is over here work done will be 0. Why? Reason is this body didn't display. This is what is the reason. This body didn't cover distance. Okay, these were 3 points. Now we have a question. Find work by force F from A to B. Okay, F from A to B. Clear? A to B. Figure is something like this. Something like this. And the acting applied force is in this direction, F whose value is 20 Newton, by making an angle of 60 degree on horizontal, and displacement is 6 meter. This is our figure. Try to visualize carefully. Then you will understand what is equation saying. It is a body. We have only one body. Okay. Right now in this figure, only one body, not two bodies. So a body which displaced from here to here, from A to B, by covering 6 meter distance. Okay. And force was applied. Force was applied in this direction. Means we pulled this object by making an angle of 60 degree. So force was 20 Newton. Force is given, which is 20 Newton. And S is also given, which is 6 meter. Can't you find work done by work force? Yeah, you can find. Even angle is given. We can say F into A is cos theta. Cos theta. We wrote cos theta because question is providing angle. That's why. If a question is providing angle, then you can write cos theta. We wrote this cos theta. Reason is W is a scalar quantity. W is a scalar quantity. Now we have all values of F and S. So F is a 20, S is a 6, cos is 60, cos is 60. So 120 cos 60 would be 1 by 2. Yeah, 1 by 2. So 1 by 2, 60. So our work done by force is a 60 joule. Remember, joule is a unit of a work. Joule is a unit of a work. That is how you will solve. Okay. How to write in vector form? How to write in vector form? So my answer would be in vector form. Here W will be equal to F vector R vector. So here F vector will be our I cap Fx plus J cap Fy plus K cap Fz. When it comes to R, then you can say I cap X plus J cap Y plus K cap Z. That is how you will write. Okay. I cap and your X value, J cap and your Y value, and K cap Z value of a force. Okay, Z value of a 4. Over here, X value of displacement, Y value of displacement, and Z value of displacement. This is how you will write in vector form. F vector and R vector. Note the force of gravity. It's gravitational force. The force of gravity is an example of a constant force. You know, this is A is equal to 10 meter per second raised to power 2. This is an example of a constant force. Here we take always 10 meter per second until and unless a question is mentioned. Okay, question is mentioned. So hence work done by it means work done by gravity is the example of work done by a constant force. Over here you can say this is a force. Which kind of a force? Gravitational force. So this gravitational force is our constant force. Is it a variable force? No, because reason is it does not change itself. Wherever we put it, negative will come, positive will come according to position of object. Okay. So value, magnitude will be same. That's why we say that this is known as a constant force. Okay. Now next we have again one question. Question is coming again and again. It is useful. Question is coming, then this is not boring thing. Kishan. A force two I cap plus 3j cap plus 4k cap is in Newton. Displace a particle from point A 0, 3, 5, 3, 5 aim to a point B 4, 4, 2. Then find work done by this force. Next question is a different from the previous. Whatever we saw in the previous question, little bit. There would be little bit of difference. Okay, not too much. So value of a force is given. A force whose values is 2i cap plus 3j cap plus 4k cap. Okay, displace a particle point from over here whose coordinates are 0, 3, 5, and when it displaced from A to B, so it reached a coordinate whose coordinates are 4, 2. Okay, in meter. Then find work done by this force. What will work done? There is no angle. Yeah, there is no angle. Over here, F is given. You can write F is given 2i cap, which is 2i cap plus 3j cap plus 4k cap. What is the displacement? Displacement is what? Final according to A position, the displacement would be final minus initial. R final minus R initial. Okay, R over here is position vector. Okay, R over here is position vector. So 4 minus 0 will be 4 minus 0, 4 raised to power 2 plus 4 minus 3, 2 minus 5. So this will be our 3. 4 4 is 16, 1 9, 15 16. 4 4 is 16. So 4 is a displacement. 4 is a displacement. So you can say 4 is our displacement. Okay. Work done will be F into S. Cos theta is not given. So F is 2i cap plus 3j cap plus 4k, and just multiply all this by 4. You will get how much? And answer should come without a direction. Answer should come without a direction. Look at over here. So displacement is nothing but R final minus R initial. So over here answer will be 4i cap plus j I cap plus minus 3 I cap minus 3 I cap. Try to solve over here. We have to write this displacement in vector form. The reason is f is given in vector. That is what is the reason. So 0 minus 4 will be our 4 I cap. Okay, plus 4 minus 3. 4 minus 3 j cap minus 3 k cap. This will be our position vector. Okay, so whose values is 4 I cap plus j I cap minus 3 k cap. Got it? Now over here we are applying a scalar dot product, a scalar product. So you know we just multiply this 4, 2 4s are 8 I cap, not I cap. Plus 3 ones are 3 and over here plus minus minus 4 3s are 12. 12 minus 12 11 minus 1. 4 2s are 8 and 3 ones are 3. 4 3s are 12. This is our minus and minus. 2 4s are 8 and 3 ones are 3. 4 3s are 12. So answer is 8 minus 15 minus 7 minus 7. This is our answer. Okay. Whatever we saw, force was constant. Now work done by a variable force. Now we are going to take force which will be variable. Okay, variable. When the force F is an arbitrary function of a position, we need the techniques of a calculus to evaluate the work done by it. In short, we are going to use calculus so that we can find variable. We can find work done where force is a variable. Okay, that is also very simple. One thing you have to keep in mind is SI unit of work done is going to be joule. Okay, and we represent joule by J letter. Okay, now over here something else. Look, there is a ball and ball is coming downward. Okay, downward on the earth. This is ball on the earth. This is coming. Question is what will be work done by gravitation force. Here you can see there is a motion of a ball which is a motion under gravity. So that's why our question will be what? Work done by gravitational force. Work done by gravity. Okay. So if force is a downward, and you can see displacement is also downward. Displacement is also downward. What is the coming theta as a angle? You would say 0. Yeah, 0. Reason is same direction of force and displacement is in same direction. That's why angle is a 0. Angle is a 0. angle is zero, it doesn't mean that force will be zero. No, angle is zero, work done is not zero. So you can say work done by gravity will be our F into displacement cos theta. Cos theta. So over here, a cos theta is 1. Okay, 1. So final would be F into S. This equation you will use. This is a very familiar. So WC is equal to F into S, where theta is a 0. Theta is a 0. 0 means direction of a displacement, displacing object, and uh, force is the same. This is what is the meaning of the 0 degree. When a body at rest starts falling freely, okay, this is body. Now, when I will drop this marker from here, what will happen? This will come in motion under gravity. So the motion of a gravity over here, this will cover some height, or we can consider it this a height right now. Just for it, we can consider this a height as a displacement. So of course this is going to cover displacement. So displacement we got, and second, which is a force direction. So force direction is a downward, which is known as a gravitational force. So direction, our focus is on direction. So direction is a downward of a force, and the direction of displacing this object is also same. So theta is going to be 0. Now when, so that's why remember here this work is not 0, theta is 0. So work done is a positive or negative, you would say work done is going to be positive. Clear? Now this same figure, we will take, and work done will be something else. If object, I am over here, okay, I am over on the earth, and I am throwing this object upward, okay, upward over here. It reached over here. Now what will happen? So I want to know what is the work done by gravitational force when I throw upward. So if you are taking downward as a positive angle, if you don't want to care about this upward downward, so okay, no problem. Just see what is the angle. Okay, just see what is the angle. Here I thrown upward means force is upward. Okay, force is upward. The force is upward, remember. And body is also going upward from over till here. Over here, you can see displacement is also in same direction, isn't it? So theta will be 0. So work done will be same. Now next, a spring. When a spring is stretched, you take a spring and just stretch that spring, then see what will happen. So displacement, you will see that there is a displacement of a spring when we apply force, some Newton. So displacement and stretching force or restoring force, okay, you can escape natural length. So when a spring is stretched, displacement and stretching force both are in the same. Try to understand. Natural length of the spring was that this much. Okay, this was natural length of the spring. When we stretched this natural length, and it went over here. So you can see this is our x displacement. Am I correct? Yeah. Now you have to see force that you applied. So what was the direction of a force that you applied? In this direction, you put this spring. So direction is in this direction. I am talking about your force that you applied. So you applied in this direction, and x is in the same direction. X is the same direction. Displacement. Displacement. Over here, theta is also again 0. Theta is also again 0. Reason is force is the same. If you apply, if you push the string, right? If you push the string, then what will happen? Displacement over here, displacement is in this direction. This is our displacement, and we applied in opposite direction. So over here, theta will be our 180, remember. And in this case, theta is going to be 0. So work done will be negative. Work done by a spring force will be negative. Clear? Positive, not negative. And work done by again a spring whose angle was 180 degree will be our negative. Okay. If 180 angle is coming, then our work is going to be negative. Case number 2. This was a case number 1. In the case number 1, we saw that the direction of both displacement and force was the same. In first case, that is what we realized. Now case number 2 is F is equal to F cos theta, where F is a, right now F is a scalar quantity, S is also a scalar quantity, cos theta. Now this case 2 is the same. If the angle is obtuse, means our angle is greater than 90 degree. This is known as obtuse angle. Case number 2 is the same. If angle is obtuse, obtuse, then as we saw our concept before it, we saw that if angle is obtuse, then work done will be negative. If angle is acute, then work done will be positive. If work done is if angle is 90, so work done will be 0, neither negative nor positive. Acute, positive work; obtuse, negative work; 90, so but 0 work. Okay. Then the work is known as to be negative. Yeah. This will be negative work. I am telling you, all these are main points. It shows that the direction of a force is such that if a direction is in this direction, or you can say backward, direction of a force was backward. Okay, so our displacement, direction of our displacement would be forward. This is what we are saying when we say work is negative, or you can say opposite direction. It shows that the direction of a force is such that it opposes the motion of the object. Means try to understand. Again, I would like to take a box just for an example. Okay, for an example, this is a box which is on earth. If I apply force in this direction with 20 Newton, but object is displacing in the opposite direction, by covering it covered, let's say 5 meter. Okay, it happens when we apply less force on object, then what happens? Object comes in opposite direction, but we applied some Newton, which was 20 Newton. It happens in a real life, yeah. So 20 Newton we applied, and displacement by the body was 5 meter. Here you can say direction is opposite. So over here theta, this is a 180 degree angle. So work done by this phenomena will be our negative. Okay. Reason is very simple. If you want to find negatives and positives, and then you will have to observe what is the angle. If angle is obtuse, your work done will be negative. If angle is acute, then your work done will be positive. If angle is 90, work done will be 0. Clear? One example, this wall is going upward, clear, from downward to upward, like this. What do you think? This will be our negative work done by gravitational force. Gravitational force. This will be our negative force by gravitational force. Try to understand. We applied upward force. Okay, upward force. But here displacement will be negative. Work done by frictional force is a negative. Over here, there is a friction which is coming out. So frictional force is a negative when it opposes the motion. So friction is what? Air friction, air resistance. So air resistance, this works as a friction. So when it opposes the motion and work done by braking forces on the car is a negative. Over here, if there is a air resistance, okay, air, then we will see that air is stopping the object which is going upward. So that's why work done by gravitational force, sometimes we will say that work done by gravitational force is a negative. Reason is there is a air resistance. If there is no air resistance, then our work done by gravitational force will be positive. If there is no air resistance, okay, in the sky, then work done by frictional force, yeah, we have seen. Case number third, let's see case number third. Case number third. Again, formula will be same. F is cos theta. F is cos theta. We have a circle. Right now, whatever I will share with you will be fact. Center. This is known as the center O, and over here we have radius. So F is in this direction. Force is this radius is a force which is known as a centripetal force. We will see it in later in separate chapter. But right now, just understand this radius is known as a centripetal force. We have a stone which is bound by thread salt. Over here you can see there is a stone. Now let me complete this question. This is going in this direction by making 90 degree angle. Theta over here is 90 degree angle. Okay. Direction is anti-clockwise. Result would be W is equal to 0. Try to understand. There is an object which is moving in this circumference. Final question is work done by this phenomena will be what? Will be how much? So here you can see I wrote W is equal to 0. Work done is a 0. But reason? I am asking what is the reason? You can say that initially object was over here. If object comes over here, then work done will not be 0. But again I am telling you, work done will be 0. Reason? We are depend on theta. So this is force, which is a centripetal force in this direction. Centripetal force. And the object is going in which direction? Upward. So between them theta is 90 degree. If you put theta as a 90 degree in your formula, then work done will be also 0. work done will come out as a 0. So force is like this, and object is moving in this direction. So of course work done will be 0. Clear? Clear? Body is a displacing. I am not asking only displacement. I am asking work done. Okay, work done. If I ask only displacement, you would say 2 pi. 2 pi r. 2 pi r is a displacement of this circle. But work done will be 0. It is depend on theta. Clear? So value of work done will be 0 if f is equal to 0 and s is equal to 0. So theta will be 90 degree. 90 degree. Body moving with uniform velocity. V is over here constant. V is a constant. If object is moving with constant velocity on this circle, so net work will be 0. Net work will be 0. Remember, if V is a constant, okay. Net force on the particle is 0. Yeah, we push the ball and it remains at rest. You see, I have this board. Okay, I am going to apply some Newton on this board. What will happen? Will this board display itself? Your answer would be no. But still I am applying force. I am still applying force. But this ball, or you can say board, is not covering distance when I applied force. So over here, work done by me will be what? You would say 0. Reason is there is no displacement. There was a force, but there is no displacement. Okay, that's why work done will be 0. A pendulum is oscillating. If a pendulum is oscillating, pendulum like this. So over here, work done by tension. Work done by tension. Look at over. This is pendulum. There is a bob, and it is going in this direction. So it is asking work done by this pendulum. This string. Work done by this string will be how much? So remember, string work done by this will be 0. Work done by string will be 0 always. There is a no displacement. Okay, there is a no displacement of this string. You can see no displacement. Is it going over here? No. Displacement is the same. Displacement is the same. Electron is moving around the nucleus. We will say it later. Satellite is moving around the Earth. It is working like this. So let's say this is a satellite. Satellite is moving around this Earth. Velocity is 0, constant. So what do you think? If velocity is constant and satellite is moving around the Earth, reason is centripetal force. So centripetal force is towards the Earth, towards the center of the Earth. So this is our force, which is a centripetal force, and direction is always tangential. You can say tangential. Tangential is the direction of a object on this circular path. Okay, circular path. So if this is a direction of the object, so between them angle will be how much? 90 degree. So 90 degree provides 0 work done. Dependency on frame of reference. Try to understand. A force does not depend on frame of reference and assumes same value in all frames of references, but a displacement depends. Try to understand. Force will not depend on reference point, or you can say frame of reference. Okay, we don't need to take a reference point for force. This is the first fact. But for displacement, as we studied in multiple lectures, we saw that displacement over here will be our relative. So over here, this displacement will depend on reference point. Okay, on observer. From here, one thing you noticed is that force will not depend on reference point, but displacement will depend on reference point. Clear? Related to different reference frames. Therefore, work of a force depends on choice of a reference point. Here, work is not a reference point, but displacement will take a reference point. That's why work done will have a choice for both. For both. Now let's solve a question. If a man starts pulling the string with a rate of 4 meter per second to the power 2, find the work done by tension on block in 2 seconds. Figure is something like this. Pulley is a fixed, brother. Pulley is a fixed. Five kg of salt. Man is on the earth. This is our figure. It is a this is our complete question. question is saying, if a man starts pulling this thing from the earth, from the ground, okay, from the ground with rate of 4 meter per second, find work done by tension, by this tension. Work done by tension will be how much? On this block in 2 seconds. At in 2 seconds. In 2 seconds. In 2 seconds. Clear? Acceleration is given, which is 4 meter per second raised to power 2. You can calculate the force. Here remember, to calculate work done by tension, we need what? Force. Force. First of all, we will bring force. Then second, displacement. Okay, displacement. So force will come out by Ma. M is how much? 5 kg. Acceleration is 4. So F will be our 20. So this much force is going. This much force is being applied on 5 kg object with this much acceleration. That is what we found. 20 Newton. 20 Newton. Now, what is the displacement? Displacement. So to calculate the displacement in 2 seconds, we will use equation of a motion. The second equation, I think so. So displacement. So half 80 square half 80 square. Half 80 square. Just we are going to use what? Third equation of motion, so that we can calculate a displacement. This is what we need. So 1 by 2 and A is 4, T is T over here. This T, it is talking about this T. Mg over here is Mg is 15 Newton. So 15 minus T will be Ma. 15 minus T, Ma is how much? 20. So minus T will be equal to 20 minus 50, which is 30. So I think over here, it is not asking T, tension, okay? This is not asking tension. T, 2 and 2. So 4 displacement. Displacement is how much? 4 meter. Displacement is how much? 4 meter. But remember, this is a raised to power 4. 2 to the 4, 4 to the 8 meter. Newton is 20 Newton and the displacement is 8 meter. Now we can find the work done by tension. So if there is no angle, so F and S. So F is 20 and displacement is 8. 8 is 60, 120 joule. 120 joule. Work done by tension is how much? 160 joule. 160 joule. 8 to the 60. 8 to the 60. But hold on. Over here, our tension was at 30. Tension was 70. 5 tens of and 5 fours of 20. So force is not. External force is how much? External force is 50 minus T. 50 minus T. Let's say direction is a downward, upward. So T minus 50 is equal to Ma is 20. So this will be our 70 Newton. Over here tension is 70 Newton. It is not a work done by tension. So finally our answer would be 70 multiple 8. 560 joule. 560 joule is our work done by tension. Clear? So that is how we will calculate our tension. Tension is over here force. Okay, this force. This force. First of all, bring your force, then bring displacement, and then calculate your work done by using this formula, which is F is equal to Fs. If theta is not being provided by the equation, then you can ignore your cos theta. Okay. Final answer for this question is 560 joule. 60 joule. Next question. Look at over here. I will not write complete question because it will take too much time. There is a lot of a sentence only in one sentence. That's why I am ignoring the question. But yeah, I will read for understanding. So we can observe all the values, all questions by just a figure. So figure is something like this. This is figure. There is a card on the earth. Velocity is in this direction. And wage is, this is wage. By making theta, there is a marsh on this wage. Yeah. This is our complete question. First of all, let me read so that you can get a clarity. So that you can get clarity. Look at our brother. This is a cart. This is a cart. Complete. This is cart which is on road. Okay. A cart with a rough inclined base moves. Here friction. There is a friction. Okay. Rough means there is a friction. A rough inclined base moves in horizontal direction. In this direction. It is talking about in this cart there is a wedge. So this base of the wedge is moving in the horizontal direction. Okay, with a speed of v meter per second. With this much speed, this base of the wedge in this cart is moving in horizontal direction, not in vertical direction. Okay. If a block is placed, if a block is placed on the inclined by the theta. Inclined means there is an angle. Okay, angle would be by making some theta. If we place this block on this inclined object and given theta is less than angle of repose, find this much theta. Okay, repose. Find work done by normal reaction. Find normal reaction. Work done by normal reaction would be what? Okay. On block in time t and t. So over here velocity is Vm per second. We are going to find work done by normal reaction on this block. Remember, this card is also going with a V meter per second. So our equation would be nothing but block is a horizontal. The block is a horizontal. We will not care about vertical. Reason is Christian direct said to us that you don't need to care about vertical direction. I am just asking horizontal direction of a block. That's it. So block is a horizontal. So our and S will be V multiple T. Means a speed will be equal to V multiple T. I think this is not a speed, yeah, displacement. Displacement is equal to V multiple T. A speed is equal to displacement upon time. A speed is equal to displacement upon time. So from the distance upon time, we calculate this equation, which is V is equal to V multiple T. So over here, displacement is how much? This is our displacement. Remember, it is not a speed. Okay, so S is a displacement. So finally, we got a distance displacement, which is a VT. You know, there is no value of a V. Okay, there is no value of a T. There is no value of a mass of the block. So normal reaction would be something like this. This is our N, and mc will be downward. So this will be our mc sin theta. You know, mc sin theta. Only question is asking normal work done by normal reaction. That's it. So this is our normal. Okay, and one component horizontal will be something like this, which is n cos theta, If you take this straight vertical, this will be our 90. So 90 minus this theta. If you take this theta, so 90 minus this theta will be our this 90 minus theta. If you take this theta, then this is whole is 90. These two lines are making a angle which is a 90. But we are saying that this is theta. Let's say it would be 30 or 60. So this is a theta. So of course, to get this rotation, we will have to subtract 90, this theta from 90. Then we will get this part. Okay, this part. So 90 minus theta. And you also know that this is nothing but n cos theta, n sin theta. Okay, which one component of a normal reaction is bringing this block in horizontal direction? Your answer will be n cos theta, not n sin theta. So that's why if n sin theta is not bringing this block in horizontal direction, so you don't need to take this n sin theta, because there is no work of n sin theta for this block to bring in horizontal direction. Okay, to bring in horizontal direction. So finally, our work done by the normal reaction would be n cos theta, and you will have to multiply. This is our force. N cos theta is a force, and multiple displacement, which is V multiple T. This is our what? Work done by normal force. Okay, work done by normal force. N is cos theta. N is cos theta. Mg cos theta. Mg cos theta. Mg cos theta. Okay. Then multiple Vt. This is our displacement. Then cos angle is 90 minus theta. Mg cos theta. Here you know that n cos theta is equal to mg. I think mg cos theta. Simplify this. mg sin 2 theta mg sine 2 theta, mg vt sine 2 theta upon 2. This will be our final work done by normalization. mg vt, mg vt. mg is compulsory. Reason is this is going downward, so mg will be our force and vt is our displacement. Sine 2 theta, this is the angle, so cos 90 minus theta will be sine, and just understand this is our equation to calculate work done by normal reaction. mg vt sine 2 theta upon 2, sine 2 theta upon 2.